Good morning, everybody, and welcome back to Next Door NetAdmin. Now, last week, we took a look at a brand new server that I received at a client site. It's there for firewall duties. We opened it up, we took a look at the hardware inside, I pointed out some of the components, and one of the components that I pointed out was the iDRAC, the Integrated Dell Remote Access Controller. It could be controller, it could be console. I don't remember which it is. But the point is, it still works out to be an iDRAC either way. I mentioned that I have it as an iDRAC Enterprise. Today, we're going to take a look at what that looks like and why the iDRAC Enterprise is so important to me on the software end of things. We're also going to take a look at the installation process for OPNsense. I'm not going to configure it all on video because that will take far too much time. And you've got other things that you want to be doing in your day. Unlike me, as a NetAdmin, this is what I do all day. But if we have some extra time at the end of the video, I'll also go into the very basic outline of what ZFS is and how the mirroring works and why I think it's such an excellent choice for a file system. So, without any further ado, let's get on with looking at the server. Right then, so now that we have racked the server, and I've also turned it on, I went through the BIOS and I assigned a static IP address to the iDRAC so that it's reachable. Everything's cabled up. So now when we go into our browser, we can go to that IP address. We get the Integrated Dell Remote Access Controller 9, which is the current version. I've also changed the default username and password so that we have something other than the defaults, which is a good thing. This is the iDRAC, and as you can see, we are currently running the Enterprise version. There's a lot of things that you can do in the iDRAC. Most notably, you can take a look at the overview for the hardware. You can look at inventory. That will give you a list of hardware components and, more importantly, the firmware versions, so that it makes it easier for you to figure out if your firmware is up to date or not. Storage has its own menu that I'm really not going to be doing anything with because, as you have seen already, I don't have a RAID card. I have an HBA here. Configuration, most of this is something that I'm not going to touch on a regular basis. Maintenance, I am. System update is how you can actually upload updates into the iDRAC, including for BIOS, firmware, diagnostics, and other important updates that the iDRAC is capable of loading into the machine for you, which is also useful if, for example, you're running Linux or BSD or something that they don't offer a BIOS update package for. You can just load the BIOS update into the iDRAC itself, and the iDRAC will take care of that for you. And then you have iDRAC settings, which is where you set up network settings and all the rest of that jim jam. Now, iDRAC Basic is essentially telemetry only. Even iDRAC Express will give you some of this telemetry, but it will not give you the most important part, which is the virtual console. Using the virtual console here, you can actually connect to the machine remotely from a browser interface, and you can connect to the screen if you need to do any actual keyboard video monitor troubleshooting. And when you load the virtual console, I have pop-ups blocked here, but that's okay. We can just load that up anyway. You can see right now the system is powered off. I don't actually have to be there in person to push the power button. I have power controls right here. More importantly, before I do that, virtual media. We can actually load up and attach a standard ISO file, in this case the installer for our firewall software here, OPNsense. And then we can map the device. And it's mapped to a CD DVD drive. We can actually boot using this. And I'll show you how. Just power on the system. Yes, I want to execute a server power action. And in just a few moments, you'll see the screen come alive with the actual Dell splash screen, just as would be displayed on the actual monitor connected to it. There it is. This is the single most important feature to me, which is why I go for the iDRAC Enterprise. I'm gonna hit F11 to get the boot manager going. That just full screened the darn thing. Of course it did. There we go. Entering boot manager. That's what I wanted to see. Having the ability to remotely access the screen from anywhere where you have a browser connection and being able to do a virtual media boot is so invaluable. I have used this to rescue servers that were physically removed from me. That would have taken me a good 40-45 minutes for me to drive to, through heavy traffic, downtown, all the rest. But as you can see, it's perfectly capable of just booting off of the ISO file that you've connected through this virtual interface, and you can see everything it's doing exactly as if you were standing in front of it. You can control the power, you can do what you need, and once it's started, actually, fun fact, you can tell it to do a graceful shutdown, which will try to ask the operating system to shut down nicely. You can just turn off the power by pulling the plug. You can reset the system by as if you hit the reset button, which is a warm boot, or you can power cycle it, where it will turn itself off for about 5 to 10 seconds and then turn itself back on again to execute a cold boot, rather than forcing you to do power off and then power on again. You can do the both at once with just a power cycle. If you ever have a server that's completely locked up and you cannot do anything with it at all, you can still connect to the iDRAC and you can still pull the plug remotely to just clear it completely, restart it from scratch. You don't actually need to send anybody there, which is really nice. Just need to wait for this to finish mounting its file systems on the CD drive. And then I'll be able to go through the installation and we'll see what we get. There we go. Was wondering why it was taking so long, but cool. This is a new version of OPNsense. It just released a few days ago, actually. I'm not anticipating that there are any differences from previous versions. Nothing significantly notable in the installer, anyway. But by the same token, it means I have not seen this before. I have no idea how long is normal to wait for this. And I just realized I did air quotes around normal. Not that anybody can see me right now because you're staring at the same screen I am. Manual interface assignment. Yes, I'm going to do that. No, I'm not going to do any lags. No, I'm not going to do any VLANs. Yeah, okay, so that looks pretty decent. So the WAN interface name should be BGE0. And the LAN interface name should be BGE1. No, I'm not going to do any optional interfaces because I don't have any. Yes, I want to proceed. Please and thank you. For the most part, OPNsense usually does a pretty good job of auto detection, but I never leave that to chance. I always manually specify which interfaces I want as what. Because the one time auto detection doesn't do what I hope it does, it's going to throw me for a loop. So I prefer not to do that. This part about configuring all of the interfaces and everything else is actually it booting into just a regular system. And then we're going to actually trigger the install, and what it'll do is it'll clone the running configuration into a new installation. It's a different way of doing it, rather than doing something like Windows where you actually boot into an installer straight that does nothing but install your system. Right now, it's trying to get DHCP on the WAN interface, and that's not going to work for it. OPNsense also runs, by default, a DHCP server on the LAN interface. If you're doing this in most networks, if you're doing it in production, that could cause some havoc. But in this particular instance, I have the network where this is being installed segregated from where all of my clients are. So none of my clients are going to start getting DHCP leases from this brand new unconfigured server. So I'm okay with that at this point. And as soon as I get access to the actual system, I'll be able to tell it, yeah, no, I don't want you running this default IP address, and I don't want you running DHCP. Stop that. I will not be going through all of the configuration on this, just the installation. The details of configuration will be different for every network that you connect to, and so I do not expect the settings that I configure to necessarily be valid for anything that you guys do, or even other sites that I do, because everything is going to be custom for each network that you touch. And you might ask, how do you keep all of those networks straight in your mind? Sometimes I don't. Sometimes I actually have to go back and look at it and go, how did I do this? Well, the most interesting thing I think that I was going to try and demonstrate was during the installation, you get a choice of how you want to do your... sorry, my mind's gone completely blank. No, it hasn't. Your ZFS topology. You can do stripe if you're doing no redundancy. You can do mirror, or you can do some of your RAID Z layouts, I believe. But hey, we have finally booted into our running quote-unquote system. Yes, I just did air quotes again where nobody can see me. So we're in live mode, but we're going to actually start as installer. And the password for that should be OPNsense. Yes, indeed it is. Default key map is fine. We are going to install using ZFS. And then we're going to get to where I was just talking about the topology options. Stripe has no redundancy. If you do it across multiple disks, if you lose any of them, your whole installation is gone. You don't have an option for single disk, but if you have a single disk, Stripe is the correct option to use because you only have one disk. There's no redundancy to set up. Mirror, N-way mirroring, is what we're going to use in this case because I have 2 hard drives and I want ZFS to take care of the mirroring because it's really good at that. So mirror, and I'm going to choose both of my actual hard drives. I'm not going to choose the virtual floppy, which is the virtual media that the iDRAC would have available. And yes, those are the 2 hard drives I want to use. Cool. From here, like I said, it's just going to clone the live system that was set up and dump that onto the 2 hard drives. They're 1 terabyte drives, so we'll have a total of 1 terabyte of space for logging and management and all that other fun stuff, which is really more than enough. I pretty much have the 1 terabyte just so that I have lots of room for logs, because I'm also going to have web filtering set up on this, and I don't really want to have to worry about running out of space too quickly. OPNsense itself does not need 1 terabyte of space. In fact, their recommended hardware requirements only require 120 gigs of space. But it's the additional logs for the web filtering that prompted me to go with 1 terabyte disks here. Oh, good, here we go. Cloning current system. And that's just going to go through a bunch of stuff to clone the current live system onto the hard drive. Then it'll be a reboot and I'll have to start the process of configuring it all. So, ZFS. You saw the list of topologies that we had, and that's interesting information in and of itself. But what is this? And why do I like it as much as I do? Well, I'm not going to go into the full story of everything that ZFS has to offer, but I'll give you a little bit of a primer. And this is where we get a little bit technical in the language, so forgive me. Yeah, it's just gonna be a thing. ZFS, the backronym for which stands for zettabyte file system. You're familiar with megabyte, gigabyte, terabyte. Zettabyte is far and away above and beyond those, so it's intended for use at huge amounts of data scale, beyond anything that you're thinking of right now. Pretty much promised. But ZFS is built from the ground up with the idea of data resiliency in mind. I don't mean security as in protecting it from other people, but I do mean security from accidentally being deleted or corrupted. There are some ways that data can be corrupted even just while it's sitting still on storage media. It's also known as bit rot. Because of this, not just because of this, but ZFS is designed in such a way that when it's properly configured, it should be nearly impossible to lose any of your data except through administrative action, because the administrator is the one who gets to call the shots. In order to facilitate this kind of resiliency, ZFS builds a structure on the storage media that essentially is a tree. It starts at the very beginning of your file system, your drive, and then it goes down through each folder and to each file. Each piece of information has a checksum calculated. A checksum is basically, hi, I have the numbers 2, 3, and 5 in a file. These should add up to 10. 2, 3, and 5. If I look at the checksum and it's 9, then I know that something in my file is incorrect. Conversely, if I pull the file and the contents are 1, 3, and 5, that doesn't add up to 10. Again, something is incorrect. And ZFS will use this to detect any corruption in the data that's being retrieved off the disk. Each checksum is not actually stored with the file. If you have a file and the checksum, how do you know whether it's the checksum that's bad or the file that's bad? The checksum is stored in a different place. Specifically, if you have a folder with a bunch of files, the checksum for each one of those files is stored as part of the folder. So when you change a file, the checksum in the folder itself has to be updated as well. And that way you're keeping some separation between the various bits of data on the disk. Cool. So if it doesn't match, we know that something is wrong. How does it fix it? Well, if it's a stripe topology, where it's just bits and pieces of data across the disks, there is no way to correct it. A stripe topology is built for one thing and one thing only, and that is speed. Because you can write to all of your disks at once and pull data from all of your disks at once, and there's no redundancy whatsoever. A mirror, usually speaking, it's a two-way mirror where you have two disks. If you have a corrupt file, it's only going to be corrupt on one disk for the most part. And so if you look at the copy from the other disk, you can see, well, on one disk I have 1, 3, and 5. On the other disk I have 2, 3, and 5. Which one matches the checksum of 10? 2, 3, and 5. Okay, so that is a good copy. It matches the checksum. Now I'm going to transparently take that and copy it to the corrupt disk so that you're replacing corrupt data with good data. And it does this transparently. Every single time you're pulling data from the disk or writing to the disk, it's calculating the checksum and making sure that all the disks are kept in sync. It's very, very secure. You don't get as much speed benefit. It is possible to read data from multiple disks at once, but you have to write the data to both disks. And so you don't get any speed benefit out of doing it at once because each disk has to write the whole thing instead of just part of the thing. The other big disadvantage to a mirror is it takes the most space. If you have two 1 terabyte drives, well, one of them is the mirror. You only have 1 terabyte. ZFS can be extended even further to have a 3-way mirror, a 4-way mirror. How many copies of the data do you want to feel secure? That's up to you. The file system will work with it. There are more advanced options with a RAID Z1, which is analogous to a RAID 5. RAID Z2, similar to RAID 6. It can go even further to a RAID Z3, where any 3 drives can fail and you'll still be able to reconstitute your data. There are a lot of options in ZFS, but I like it because it is built from the ground up for data resiliency. I don't want there to be any chance of me losing customer data, and it works very well. Remembering what I said last week about software RAID and how when it's driver dependent, it's less performant, you might think that the same is true of ZFS, and to a very minimal degree, that might be true in some cases. Not all cases. A lot of it depends on exactly how you build it. ZFS has other features such as a cache drive, a log drive, additional cache. You can configure it to be extremely performant. The other thing is, it's not driver dependent. This is just how the file system works. Anytime you access the disk, this is what it's doing. You don't need Windows-specific drivers or Linux-specific drivers, and it doesn't have to be called as a separate operation. This is just how the disks work when they're formatted with ZFS. And so there's nothing extra about it. Why do you want an HBA if you're working with ZFS instead of a RAID card? Well, a RAID card is designed to abstract multiple disks away from the operating system, because it's too complicated and the operating system shouldn't have to worry about that. So it will present just a single virtual disk. Here is your RAID disk You may do with it as you want. Leave the disks to the RAID card. That works up to a point, but it doesn't work completely. A RAID card is really good at detecting when an entire drive fails. Cool. What if the whole drive didn't fail? What if it's just a few corrupt files here and there? The RAID card's not going to know anything about it. That's not what RAID was designed to do. And so a RAID card will, in some cases, return corrupt data because it doesn't know any better. It just happened to pull data from one of its disks, and it was corrupt. The disk itself hasn't failed. ZFS is there to detect this. But if you're using ZFS with a RAID card, the RAID card is just giving it a virtual disk. All ZFS can see is, this doesn't match. Something is corrupt. But it doesn't know what disk it came from. It doesn't know if there's another disk out there with good data that it could use instead. It really doesn't have the information that it needs in order to work correctly. And so if you're going to use ZFS, you don't use a RAID card at all, even in JBOD mode. JBOD is a term for just a bunch of disks. If you have a bunch of disks on a RAID card and they're just disks, it's not a RAID disk. Does that work? Not really. Sometimes it can, but more often you'll have to do special things to the RAID card in order to actually pass through full control of the disks to the operating system and to ZFS. Otherwise, it's going to treat them as a bunch of mini disks, and you're not going to get the full data that you need to use this effectively. So when ZFS is on the table, RAID is not. You just want an HBA, you just want a bunch of disks, and that's all you want, because ZFS will take care of it. And again, like I said, there's a lot of reasons why I like ZFS so much, and going into them all would be at least a couple more videos on its own. We'll probably cover it in future if I work with more NAS-based systems or anything else where I'm storing large amounts of data, because that's where ZFS is most useful and excels when you're managing large amounts of data. But for now, it's enough to know that, hey, this particular OPNsense system, this operating system has ZFS as an option. I'd like to use it. That's why I built the server the way I did, to take advantage of it. There we go. That's the story. All right then. So I am happy to report at this point that I was able to get the system configured, and I have been working on moving it towards production. Not quite there yet, but then I'm recording this as a piece with the video that was released last week. So I'm already in the future, and I anticipate that the future's running very smoothly. And that's a good thing. That's what NetAdmin's like, is when things run smoothly. All right, I've rambled on enough for today, I imagine. But I hope you really enjoyed being able to get a more in-depth look at how the iDRAC works, how the virtual media works, how useful it can be to be able to work with the server remotely just through a browser. And then I hope you enjoyed a little bit of the information about how ZFS works. I know it's kind of a geeky topic, but that's part of life for a NetAdmin. Thank you very much for joining me. I am your next door NetAdmin. We'll see you later.